Hi viewers, welcome to Electric Funder. In this lecture we are going to discuss about nodal analysis, which is applied to electrical circuits for solving the electrical networks. So what is a nodal analysis? Nodal analysis is a technique used to analyze circuits with more than one voltage source. Based on KCL and Ohm's law, it is used to determine the voltage of nodes in a circuit. Once we determine the node voltages, it's possible to find the currents in all the branches and power absorbed by all the branches. So let's consider an example here. So this is an example we consider here. So to solve this network by means of network analysis, there are few steps. If we follow stepwise procedure, it's a simple to solve the network. So step 1 is choose a reference node, which is generally the reference node is selected as a ground node, and assign that ground node voltage is at 0 volts and it's named as B. And step 2 is usually known node voltages with respect to the reference node. So you have to identify the known node voltage. Here Cth node is at 12 volts and Dth node is at 6 volts, and A node voltage is we don't know, so it is a question mark here. And VB is the reference node voltage. Generally usually it is taken as a 0 volts. And step 3, assume the direction of the current passing through each resistor that is adjacent to node with unknown voltage. The directions are arbitrary. Label the currents with an arrow and sense numbering schemes IR1, IR2 like that on your circuit schematic. Here we assumed that each current is going out of a node because the when you are applying a nodal analysis at node A potential is assumed to be more compared to the other nodes B, C and D. So hence the direction of current is outwards. In step 4, write KCL at the node with the unknown voltage. So at node 1, node A, the voltage we don't know, hence we have to write a KCL equation there. So there IR1 plus IR2 plus IR3 equal to 0. So express the each branch currents in terms of Ohm's law. IR1 equal to VR1 by R1, IR2 equal to VR2 by R2, IR3 equal to VR3 by R3. So later we substitute to the values of node voltages. Let us substitute the known node voltage from step 2. So then we get IR1 equal to VA minus 12 by R1, IR2 equal to V1 minus 0 by R1, IR3 equal to V1 minus 6 by R3. Now substitute the resistance values also. So finally we will get here VA minus 12 volts by 8 volt, 8.2, VA minus VA minus 0 by 10 plus V1 minus 6 by 5.6 equal to 0. So if we solve this equation, we get VA equal to 6.63 volts. Uh, Note that you know the node voltage VO. We can able to find the current through each branch and voltage across the each branch and power calculations simply. If you have two or more unknown nodes, you will have more equations to solve. So the number of nodal equations will get equal to the number of unknown nodes here. So here, for example, the two unknown nodes are there. We'll get two equations. So in this example, we considered only one unknown node, node A. So hence only got one equation. So let's take another example with two unknown voltages B and C. So B node voltage we don't know, and C node voltage we don't know. A node voltage is 3 volts and D node voltage is at 0 volts and E node is at 4 volts. So for this example, if we apply nodal analysis, we have to follow some steps as in previous case. So here the step 3 C drawing for the above currents. IR1 play at node B and C, you have to write the KCL equations. At node B, the KCL is IR1 plus IR2 plus IR3 equal to 0, and at node C, it is IR4 plus IR5 equal to IR3. Now you represent all currents in terms of nodal voltages. Later you substitute the resistance values. Um, Finally you get at node B, VB minus 3 by 1000 plus VB by 2200 plus VB minus VC by 1500 equal to 0. And in the same way at node C we will get Vc minus Vb by 1500 plus Vc minus 4 by 3300 plus Vc by 8200 equal to 0. If you solve those two equations of step 8, we will get Vb equal to 1.76 volts and Vc equal to 1.09 volts. These values are with respect to our reference node D. Thank you.